Welcome to Pastor Victor's Academy. Embark on a journey through the world of engineering mathematics and electrical engineering with our educational tutorials designed specifically for engineering students. Whether you're mastering calculus, solving complex circuit problems, or exploring power systems, Pastor Victor's Academy is your ultimate learning companion. Join us as we break down complex concepts into clear, easy-to-understand lessons, helping you build the foundational knowledge and skills needed to excel in engineering mathematics and electrical engineering courses. Subscribe now to kickstart your learning journey and gain the confidence to tackle engineering challenges head-on. Let's unlock the world of mathematics and electrical engineering together, one lesson at a time.
Hello, good day. Welcome to Pastor Victor's Academy. I'm glad you are here. You're already in 2026 and I wish you a happy new year. In this video, I'll be talking about engineering thermodynamics. So we'll be looking at the introduction to engineering thermodynamics. Please do well to pay attention as we'll continue. Thank you. I believe you've heard about thermodynamics. As long as you are in one of the engineering departments, you must have heard about thermodynamics. In secondary school, you hear about thermodynamics in physics. You also hear about thermodynamics in chemistry. So we're looking at thermodynamics in engineering. That's why it's called engineering thermodynamics. So we're not just looking at thermodynamics as a branch of science, but we are looking at how it applies to the engineering discipline. So that's the reason for the topic. Engineering thermodynamics. We'll be focusing on the introductory aspect because while I was in the higher institution, I only did the introductory aspect, considering the fact that I was in the electrical engineering department, not in mechanical engineering department. So I'll be taking you through the introductory aspect, and I believe you will learn so much from here. So the first thing we'll be looking at is what is thermodynamics, because if we don't get the definition of thermodynamics, we may not know why we'll be looking into some of the concepts we would have to look into later. So that's the essence of defining thermodynamics. Many students, the moment you talk about thermodynamics, the first thing that comes to their mind is calculation, problems. But from personal experience, I think it's good you grab definitions and concepts. When you understand definitions and concepts, you really do well in problem solving. So let's look at what thermodynamics is all about. Thermodynamics is a branch of science that studies the transformation and transfer of energy through heat, work, and mass flow, and the conditions under which these processes occur spontaneously. Of course, in physics, we look at various forms of energy. We look at heat, we look at mechanical, we look at electrical. So physics is concerned with matter and energy. But when we begin to look at how energy is transformed, energy is transferred, then we are talking about what? Thermodynamics, which is a branch of physics actually. So thermodynamics is a branch of science that studies the transformation and transfer of energy. So take note, it doesn't focus on forms of energy. It looks at the transformation and transfer of energy. Now that can happen through heat. It can also happen through work and can also happen through mass flow. So heat here has to do with difference in temperature. Then talking about mass flow, it could be the flow of what? Gas, flow of liquid. So that's it. And the conditions under which these processes occur spontaneously. So that's another aspect of what? Thermodynamics. Energy transfer or transformation through heat, through work, through mass flow, and the conditions under which the processes occur spontaneously. Take note of the keywords: transformation, transfer, energy, heat, work, mass flow, then spontaneously. So in thermodynamics, we also want to know the conditions that will make the transformation of energy or transfer of energy to be spontaneous. That's the essence of this part. We are not just looking at energy transfer or energy transformation. We're also looking at the conditions that will make that energy transfer or transformation to happen spontaneously. Now, I want you to take note of the word thermo or the term thermo. Many times when you mention thermodynamics, people begin to think about heat because the word thermo is also associated with the word thermal, which means heat. But thermodynamics is not restricted to the study of heat alone. So don't be deceived by the word, oh, since it's thermal, we are just talking about heat. No, we are talking about energy, not heat. So don't get deceived because you hear thermal and it sounds like thermal, and so it must be about heat. No, it's not just about heat, it's about energy. So heat is just one of the means through which energy is transferred. We also have work, we have mass flow. So don't limit thermodynamics to the study of heat. Thermo only shows that at conception of thermodynamics, the primary focus was heat. But as things get advancing, then it expanded into energy, not just heat. Another thing I want you to know is this: thermodynamics is a science that cuts across many disciplines. So if you're in physics, you hear about thermodynamics. You're in chemistry, you hear about thermodynamics. You're in biological sciences, you can also hear about thermodynamics. You're in engineering, you hear about thermodynamics. So each discipline applies thermodynamic principles to its own domain. So when we get to each discipline, we are looking at how the principles of thermodynamics can be applied in that particular discipline and domain. Now, physics is the discipline that gave birth to thermodynamics. And in physics, they are concerned with the fundamental laws governing energy and entropy. So if you find yourself in physics department, you'll be looking at the fundamental laws that govern what? Energy and entropy. In chemistry, thermodynamic principles are applied to chemical reactions. So those in chemistry department will be looking at what? How thermodynamic principles can be applied to what? Chemical reactions. So when this reaction happens, what amount of energy is transferred? Maybe through heat. So that's their own concern or way of application. In biology, thermodynamic principles are applied to biological and metabolic processes in living systems. So maybe in the digestion of food, it can be applied. How energy is extracted from food and stored in living organisms, and how the stored energy is used in anabolic processes. Also in engineering, thermodynamic principles are applied to the design, analysis, and optimization of physical systems and devices. So when we have an understanding of thermodynamics, we can apply the principles to the design, analysis, and optimization of what? Physical systems. Optimization has to do with the best performance of a system. So in that case, we can say that engineering thermodynamics is the application of thermodynamic principles to the design, analysis, and optimization of physical systems and devices. So the next thing we want to look at is basic concepts and definitions. So there are concepts we need to understand and definitions we also need to understand. And the primary concepts, system, boundaries, surroundings. We'll also be looking at other things, but these are the basic ones. So we have system, we have boundary, and we have surroundings. Then we can put it in a pictorial form this way to help us grab quickly what we want to talk about. So what is a system? System is whatever we want to study. It can be a quantity of matter or a region in space. So whatever you want to study in thermodynamics is called what? System. As in the case of a quantity of gas, a quantity of liquid, or a region in what? In space. It can even be a piston cylinder assembly. It can be an engine. As long as that's what you want to analyze, it is called what? System in thermodynamics. The next thing we want to look at is boundary. Boundary is an actual or hypothetical surface enclosing the system. Actual means real. Then hypothetical means what? Imaginary. You get. So which means that this is not real. It's just for the essence of what? Analysis. But in reality, that boundary does not what? Exist. So it's an actual or hypothetical surface enclosing the system or separating it from its surrounding. So you can see this will have system, in other words, a quantity of matter, maybe gas, maybe liquid. Then outside the system, we have the surroundings. Then here we have the boundary. It encloses the system and separates it from the surroundings. Now, a boundary can be fixed or movable. So don't always think that boundary must be fixed. It can be movable. For instance, you have a piston cylinder assembly. So the piston is moving within the cylinder, meaning that what? The boundary increases and what? Decreases. This is the boundary. So when the piston goes to this position, the boundary of course has what? Decreased. When it goes back to the initial position, it has increased. So a boundary can be what? Fixed. A boundary can be movable. Now let's talk about surroundings. Everything outside the system that may or may not interact with it is referred to as what? Surroundings. So the surroundings can interact with the system and the surroundings may not what? Interact with the system. It just depends on the kind of system you have. But one thing is clear, that surroundings has to do with everything outside the system. So once you are able to identify your boundary, you know that whatever outside that boundary is part of what? Your surroundings. Now let's look at types of system. First, we have open system, we have closed system, we have adiabatic system, we have isolated system, homogeneous system, and heterogeneous system. So for the open system, it permits the flow of matter across its boundary. It is also called a control volume. So another name for this is control volume. What makes it an open system? Matter can flow. You get? So matter can flow from the system to its what? Surrounding. Take for instance a cylinder containing air, and air flows from that cylinder to the what? Surrounding. Take for instance a cylinder containing water. You are heating water in a cylinder or even in a pot. At a point, water vapor begins to move out from the pot and enter the surrounding. So it permits the flow of what? Matter across the boundary. That's why it's called open system. Now, for closed system, it does not permit the flow of matter across its boundary. Now, you can imagine a container having a fluid inside and is sealed. Of course, matter cannot flow out from that container. Maybe air, maybe liquid, maybe water. Whatever is in that container cannot flow out of that container to the surroundings. So that's why it's called closed. It does not permit the flow of matter across its boundary. But that doesn't mean that there can't be energy transfer. Energy, of course, can be transferred across the boundary in the form of heat or work. Now, assuming I have chemicals inside this container and it's sealed, when a chemical reaction happens here and produces heat, if this container can allow the flow of heat, you notice that you begin to feel heat outside the container. Not because there was flow of matter across, but because there was flow of energy across the boundary. So matter is still there, but energy has passed through through the boundary. So that's why it's called closed system. Matter cannot flow out, but energy can flow out. Now, in the case of energy flowing out in terms of work, if you have a piston cylinder assembly, because this piston is moving, that energy transfer is by work, because the movement transfers energy. So the energy transfer is by work. There can also be energy transfer by heat, because in the course of the movement, of course, we are expecting chemical reaction to happen, which will also generate heat energy that can flow across the boundary. So that's for closed system. Energy can flow across the boundary in form of heat or work, but matter cannot do what? Cannot flow out. Then we have the next one, a diabatic system. What makes it what? Adiabatic. It is thermally insulated from its surroundings. So please take note of this. An adiabatic system is already a closed system, but a closed system must not be an adiabatic system. So every adiabatic system is insulated from the surroundings. So transfer of energy cannot happen through mass flow or heat. It can only happen through work. So that's why it's called a diabatic system. Now you can see the progression from open system to isolated system. Initially, energy could flow across the boundary through mass flow, heat, and work. But we said no, we just want energy to flow through heat and work alone. Then that gave birth to the closed system. The moment we closed the open system, mass can't flow, which gives birth to what? Closed system. Energy can flow in the form of heat. Energy can also flow in the form of what? Work. Now, what gave birth to a diabatic system? We said, okay, we just want energy to flow across the boundary in the form of work. So we don't want energy transfer by heat. In other words, we insulated the closed system, which gave birth to what? A diabatic system. You get? Then we finally said, okay, we don't want the system to interact in any way with the surrounding. In other words, there shouldn't be any form of what? Energy transfer. Then, after insulating the closed system that gave birth to the diabatic system, we isolated the system. In other words, there is no energy transfer by what? Work. So for the isolated system, it does not interact in any way with its surroundings. Finally, we have homogeneous and heterogeneous systems. Homogeneous system is a system that comprises of just one phase of matter, whereas heterogeneous system comprises of more than one phase of matter. So when we're looking at one phase of matter, we are looking at a homogeneous system. But when we are looking at more than one phase of matter, we are looking at what? A heterogeneous system. That brings us to the end of this video. In my next video, we'll continue with basic concepts and definitions. Please like, share, comment, and subscribe. If you find my video helpful, please share and do well to subscribe. Thank you for watching. God bless you.